Yes, now we are going to discuss another category of a very important reaction of aromatic amines, that is electrophilic substitution reactions. Fine. Till now, regarding aromatic amines, we were just discussing the reactions in which this NH2 part of the aromatic amines is taking part in the reaction. We have discussed reactions due to NH2 group. But now, if the substitution takes place in the ring, we know the most common reaction of the ring is electrophilic substitution reactions, which also take place in this case. So now we are going to discuss the reactions due to the benzene ring, right? Now here we see the benzene ring is not alone, it's not benzene, it is aniline, that is NH2 group is attached to the benzene ring. Now we know that benzene ring is a very good source of pi electrons. Therefore electrophile, that means those substances which need electron, they usually attack benzene ring. Fine. And moreover, due to presence of NH2 group, we have seen here that due to the plus R effect here, that is N-pi conjugation, we see that the lone pairs from nitrogen, they shift towards benzene ring. We have already discussed these structures in the basic character of aniline. If you see these structures carefully, then you see that due to this effect, there comes electron density in the ring at various particular positions, that is ortho, para and ortho position. Or in general you can say that NH2 group is highly activating group which increases the electron density in the ring. As a result, aniline is more reactive than benzene towards electrophilic substitution reactions. For example, if an electrophile E positive is to attack on the ring of aniline or on the ring of benzene, then this step is a very fast reaction in case of aniline, because there is a very high electron density present in the ring in case when NH2 group is attached to the ring. Now, NH2 being a highly activating group, what we usually find, if the substitution is carried out without any protection, then substitution at all available position in the ring takes place. And usually we will get substitution at all available positions where the electron density is maximum, that is ortho, para and ortho position. So the product we usually get is 2, 4, 6 tri-substituted products. Though in some cases we get unusual products also. For example, I have taken here the first example of electrophilic substitution reaction, that is halogenation. I have taken bromination. This is bromination of aniline. When aniline reacts with the bromine water, you see here Br positive is the electrophile which attacks the benzene ring, and you see here we just wanted mono-substituted derivatives, that is only one Br is present at ortho plus one para product, but unusually we get bromine attached at all the available position of the ring, and we get 2, 4, 6 tri-bromoaniline as a product. Fine. So this is due to highly activating NH2 group which makes the benzene ring highly susceptible towards electrophile. Therefore electrophile gets attached at all the available positions. Fine. Now let's discuss, but sometime we do not require such tri-substituted products. Sometimes we require mono-substituted products. So what to do in that case? Let's see, if we want some mono-substituted products, then what extra step has to be taken? So it has been found that if aniline before undergoing electrophilic substitution reaction is acetylated by treating with the acid chloride or acid anhydride, if it is acetylated, we have just discussed this reaction earlier, right? So there is a presence of acetyl group on the nitrogen, that is acylation reaction which we have just discussed. So this is how we have introduced this group on the nitrogen of the aniline. Now let's see what is the benefit of introducing such a group on the nitrogen attached to benzene. The problem of getting tri-substituted products, high electron density in the ring, was due to lone pair present on the nitrogen. But we see, if such a group is attached to nitrogen, then though nitrogen is shifting its electron towards the ring, but in this case there will be less shifting towards the ring because one more group is here, that is carbonyl group, in which carbon is partially positive. So the electron delocalization takes place in this direction like this. Fine. As a result, if we see its contributing structure, then we'll find here that nitrogen becomes electron deficient. The availability of lone pair on nitrogen is very less. So if such a group is attached which attracts these electrons towards itself, therefore they are very less shifting towards benzene ring due to plus R effect. As a result, this benzene ring becomes less active towards electrophiles. Therefore, we can control this electrophilic substitution to mono substitution rather than tri-substitution. Let's do one reaction, that is bromination. So before bromination, I have made this product by introducing acetyl group here, right? So this compound we have, this is N-phenyl ethanamide. Fine. Now let's start its bromination now. Now if it reacts with bromine, then you get usual mono substituted product, that is ortho bromo. This common name for this is acetanilide. So this compound is ortho-bromo-acetanilide plus another mono substituted product, which were the expected products, that is para. Para is the major product in this case, so ortho is minor due to steric hindrance present at ortho position. Fine. But ultimately we want here NH2 group, so we have to remove this acetyl group. So for that we use hydrolysis in acidic medium. So these groups are further reduced to NH2 group by hydrolysis, plus we have got 2 molecules of acetic acid. Fine. So you have got normal mono substituted product, that is ortho-bromoaniline and para-bromoaniline, which you cannot get by direct bromination of aniline. So to reach up to this mono substituted products, we have to first acetylate aniline. So it is usually, this question is asked in exam, that why aniline is made to undergo acetylation before electrophilic substitution or before bromination, like that. Fine. So the reason is very clear. When such a group is attached to nitrogen, the nitrogen becomes a less activating group. This group is a less activating group, so ring is not that much highly activated. As a result, the substitution takes place at normal position. So this is very important regarding bromination. Let's discuss next electrophilic substitution now. That is, we have nitrogen.